Hi everyone, today we are going to finish up talking about activity 26 and parabolas with a little extra examples about them. Reminder, a parabola is a set of points that are equidistant from a point called the focus and a line called the directrix. And in the middle of those two points, the focus and the directrix, we have our vertex point, which we identify as h comma k. So inside of here then would be our vertex point. Okay, but it's equidistant between that directrix line and the focus point that it opens towards. And we have both vertical and horizontal parabolas. Our vertical parabolas, reminder, are y minus k equals 1 over 4 times d, x minus h quantity squared. And basically everything flip-flops when it goes the other direction because it is now our y variable that is squared in this. Now, h comma k is always our vertex, and reminder that h and k, h always goes with our x values, wherever those are at, and the y always goes with the k values, wherever that's at. So notice they're always kind of buddies in there. And then again, if it's positive d value, it's opening up. And then the negative d value means it opens down, while the reverse happens over here. The vertex is still h comma k, but positive d means that the overall parabola opens to the right versus the negative, which means it opens to the left. Now, we talked a little bit about examples in the last lesson about when we are given a focus and a vertex. Now we also want to be able to write these given a vertex and a directrix and a focus and a directrix. And again, I recommend draw a pick. Okay, draw a little pick to help you jot down your ideas. So our vertex, again, is our h comma k. And this time, if our vertex is at 0 comma 4, and our vertex is a vertical line through 1/8. So we're talking real close here to this line. And again, because it's x equals, what we know is that our parabola opens away from the vertex towards our focus, which would probably be somewhere over here, right on this other side. So we know we have a leftward facing parabola, which means that we're going to have a y squared. It's going to be a negative value because it's opening to the left. There's a lot going on with that. So if we use the general form out, x minus h equals 1 over 4d y minus k quantity squared. And again, we know that this is negative this time because we're opening to the left. We now want to think about what is this d value. Well, to get from 0 to 1/8, right, we are 1/8 to the right. That means that our d value has to be 1/8 as well, right? Because we're moving from 0 to 1/8. So as we start plugging some things in, we have h and k are 0 and 4. And this time we have that d is 1/8. And when we simplify, we get x equals negative 1 over 4 times 1/8, which is 1/2, y minus 4 quantity squared. And then last but not least, you always want to simplify as much as possible here, that we don't want to leave this as negative 1 over 1/2. That's kind of ugly. Got to multiply by that reciprocal, and it became negative 2 instead. Now, in the next example, we're given the focus and the directrix. Now, the focus is at 6 comma 2. The directrix then is a horizontal line through negative 4. So what this tells us is that our vertex has to be directly in the middle of positive 2 and negative 4. This total distance here, this is 6 units, right, from positive 2 to negative 4, which means halfway between there, 3 units between each of these is where this vertex is going to occur, and it's going to have to open upwards to be towards our focus. Okay. Now, again, we know that that distance between the vertex and the focus and the vertex and the directrix was 3, half of that total distance, because again, it's going back to the definition, equidistant between those points. And we also know, again, that the x squared is going to be the squared term, and it's positive because it's opening upward. Okay. So when we plug into the formula, it's y minus k this time, 1 over 4d, positive because we're opening upwards, x minus h quantity squared. And when we start plugging in, this time we also are going to be responsible for finding the vertex. Now, it's going to actually have that same x point 6, but again, it went 3 units below 2 to negative 1, or 3 units above negative 4 to again be at 6 comma negative 1, which would be our h and our k. So negative 1 and 6. And then our d value we said was 3. And so finally we have y minus negative 1, y plus 1, 1 over 12, x minus 6, quantity squared. All right, last example for today is a word problem. So it's on the back of these notes, or if you're taking notes in your own notebook, follow along. It says we have a satellite dish that is shaped like a paraboloid of revolution. The signal that travels to a satellite strike on the surface of the dish and are reflected back to a single point where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep, at its center, at what position is the receiver placed? So let's start by making this as easy as possible on ourselves by drawing a picture and making the picture most useful to us. Okay, let's make this vertex just at 0, 0 to make our lives as easy as possible. Okay, and then it says that we have a dish that is 8 feet across at its opening. So wherever this opening is at between these 2 points is going to be 8 feet. Okay. And we're basically trying to figure out where the location of this focus would be at inside here, because it's going to need to have that correct reflective piece of this. Okay. Now, it says that these are 3 feet deep from the center. Okay, so something we can note here is that if these are 3 feet deep, that means that this distance would be 3 feet, which means if we made this again 0, 0, this would be 4, 3, this would be negative 4, 3. And ultimately, again, we need this distance here from here to here. So we're using some points from our picture to help us figure out what that distance would have to be. So if this is going to be an upward facing parabola, well, I guess we could plug this in. We have h and k. So y minus 0 equals 1 over 4d, x minus 0, quantity squared. And this time, again, we're going to pick one of these 2 points, either negative 4, 3 or positive 4, 3, to plug in for our x and our y to help us figure out what this distance is. And again, we could have really put the vertex and these points, as long as they kind of have that same 8 foot, 3 foot anywhere, because this distance should come out to be the same, but we're just making it as easy as possible on ourselves for simplifying. So that also being said, I'm going to use 4 and 3 because those are positive values. And suppose the negative 4 and 3, again, I'm just trying to make it simple on myself. So we have 3 equals 1 over 4d times 4 minus 0 squared, which is 16. So in this case, if we take 1/4 of 16, we end up with 4 over d. And then to help us finish solving, we end up with 3 times d equals 4. Cross multiply, d is 4/3. Okay, so that distance here, if we're looking at our particular picture, we would want this receiver focused at 0, 4/3. as the position where this should be kept. So should be at 0 of our. And we will definitely be working more with word problems in the future for all of our conic sections, but this is kind of a little introduction to setting one up and solving for that missing piece. Okay. Thanks everyone for watching. We'll work more with parabolas in class.